Hello and welcome to another video. Been a while since I made a video, but I should be able to make them more consistently now. So in this one, we're going to be doing longest square streak in an array. And here you're given an integer array nums, and a subsequence of nums is called a square streak if the length is at least 2, and after sorting it, every element is a square of the previous number. So you want to turn the length of the longest square streak, or -1 if there's not. And a subsequence just means you can delete anything you want without changing the order of the remaining elements. So in this example, it's this, because sorting it gives you 3. And then, so you'd get 3. And second one, there is no subsequence that, there's not even one pair, so there's nothing here. So the main thing to recognize here is because you can sort your subsequence once you get it, the order of this array doesn't matter at all. Like, you can basically just arbitrarily pick a bunch of numbers. And as long as those make that square root streak that we're looking for, then that's fine, right? We can just say if this and this and this, let's say, make that streak, we can kind of move them around in the way we want, and then it's fine. So the order doesn't matter at all, which means there's a few ways to do this basically. But basically what you're looking for is given a number, you can just check is that number squared in here? 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 And so on. But you want to kind of use efficiently, because let's say we had a bunch of numbers that were let's say our array was literally just 2, 4, 8, 16, or not 2, 4, 8, 16, 2, 4, 16, 64, and then whatever 64 squared is, and so on, and so on, and so on. Well, if we check for this streak, that's good. But then what if we also start at 16 and then we also check for this and then we check for this and so on? So you can imagine if we just had a bunch of numbers that were one after the other, after the other, after the other, maybe it actually won't even matter because they're squared. Maybe the space is small enough to where it's squared numbers, it doesn't actually even matter. But let's say your problem wasn't squared, it was every number is the number before times 2 or something. You want to find a way to do this efficiently. And so for all these questions where you're basically said okay, give me the longest sequence where some pattern happens, it's really easy to do if you just think of one thing. Basically this sequence, right, this longest sequence is going to start with something and end with something. So if I'm given a number, let's say here, if I'm given 664, I want to check, do I even want to start? Ideally I want to start with the smallest number in my longest streak, which would be 2. And so the way to check really quickly is, do I even want to start with 64? To check well, is the square root of 64 in here? And actually, now that I'm thinking about it, this should not be 64. This should be 16 squared, right? And then 16 to the 4th and so on. But let's say I get that. So think 16 squared is 256 or something. Who knows? Maybe it is. Maybe it's not. Okay, but anyway. Hopefully it is. So let's say I'm given this 256 and I'm asked should I start with this? Well, I can just check, is the square root of my number in my array, in my whatever numbers I have? And if the square root of my number is in my stuff, then the sequence that has 256, if the square root of 256 is also in here, then why would I start with 256? I would just want to start with the one before. So that's kind of the way to solve all these problems where you're trying to say what's the longest consecutive thing. Same thing with if the question was give the longest subsequence where every number is the number 4 times 2, you would just get a number x and you check well, is x over 2 in my array? And if it is, then something starting with x is never going to be good, because I can just start here and then that will give me whatever this is but more. So that's kind of the idea. So we don't actually need to sort here. One of the ways is to sort, but we don't actually need to sort. So we can basically just store these in a set like this. And then every time we go through the number, we can just check is the square root of that number in here? And if it's not, then that number will be the start of some unique streak. And then for that number, we do have to check what's the longest streak. And then from there, it's pretty easy, right? If we start with 2, we just check is 4 in there, is 4 squared in there, and we just keep going until we're done. But essentially, this is basically give us a no-event solution, because with most numbers, we're not going to traverse the whole thing. We'll just say we don't care. But then with only numbers that are the start of each unique streak, then we'll use those. So let's kind of walk through how that's going to work. So with 4, we'll basically check okay, is 2 in here? It is, so we don't care about 4, because we're never going to use 4. Is the square root of 3 in here? No, it's not. So we do care about 3. So we'll just say, like, okay, we have 3. Do we have 9? No, we don't. So our longest streak with the 3 is just 1, which is no good because we need a streak of at least 2. Same thing here. Is the square root of 6 in here? No, it's not. So 6 is a valid start. Is 36 in here? No, it's not. So we're done. 16. Is the square root of 16 here? Yes. So we're never going to use 16. Is the square root of 8 in here? No. So we're going to start with 8. Then we'll check for 64, which isn't in here. So that also gives a streak of 1. And then here we'll check, is the square root of 2 in here? No. So we'll start with 2. And then we also have 4. And then we also have 16. And so our longest streak is 3. So basically say, like, okay, we have 2. Let's square 2. We have 4, let's square 4, we have 4, let's square 4, and we just keep doing that until we run out of numbers. But that's kind of the idea. You always want to start with a number that's the start of the streak, and then to know if the number is the start of the streak, just check if is the one before that present in here, and if it's not, then start with that number and just look for the longest thing. So pretty easy. And then basically with these, there will never be a number before, but there will also never be a number after, so the longest streak you'll get was 1, so you'll just get -1. So there's like a couple problems like this. Like I said, there's like a double of the previous number plus 1, all these things, and you can basically do them all this way without having to sort. Where essentially you can just take now in order to do this, you have to be able to take a subsequence of numbers, and then you have to be able to rearrange them. And we are allowed to do that, or we are allowed to sort, so that works. So that's what we'll do. Okay, so we don't need to sort, we just need a set, so we'll just say like set. And I don't know if you can have duplicates, but even if you can, like, duplicates won't change the answer here, so it doesn't really matter. And we won't have duplicates by doing this anyway, so. And then for nums. Alright. So basically what we want to do is we can just have a result, and we'll just say equals 1, because you can always have a streak of 1, which is just the number itself. Now we want to loop through all of our numbers in the unique set, so we could say like int uniques. And the reason we want to have a set is because we want to have O1 lookups, like is the next number in here, and with an array you wouldn't be able to do that. So anyway, here we can just check like if the square root of this number is in here, so math square root. Actually, we probably have to calculate it, so we can say like int square root equals math square root of this number. And this will technically give us a double, but we can kind of do a little trick. We can just say, let's convert it to an int. And then let's just check, is this actually the square root? And then the other thing we need to do, I think, so I think in the constraints, this is 10 to the 5th, so 10 to the 5th squared might give you an overflow. So we can also not make sure we never take the square of a number that's bigger than like 1,000. Because 1,000 squared will be 10 to the 6th, and we'll never have 10 to the 6th in here because this is a constraint. Alternatively, you could use like longs or something for your numbers, and then you won't run into that issue. So one or the other. Yeah, so we can just say like, we have the square root, then we'll have our current streak. And we'll say while the square root times square root, or actually, we don't need to do that. We can say if square root times square root. So this square root won't actually be like the real square root. So for example, square root of 3 will be like 1 point something. And then when we convert that to an integer, we'll just get 1. So we have to check, like, is this squared actually the number? You could use doubles instead. Either one's fine. But anyway, if this is, if you're using a language without like types, then you can just do this. Then you'll know this will actually be the square root. But anyway, if the square root equals number, or doesn't equal number, I guess. Actually, if the square root doesn't equal the number, or if the square root actually exists, so if the square root doesn't equal the number, actually no, sorry. If the square root equals a number, because this has to be like an integer square root, right? Like if we have 3, we'll never have the square root of 3 in our array. So if the square root equals a number and uniques has this square root, then we basically never want to start with the number, because the square root will just be the number before that in the sequence, right? So if we have like 4, but we also have 2, then why would we start with 4? We're just going to skip 4. Alternatively, what you could do is you could like go down to the closest number, but there's no need of doing that. So I think this is easier anyway. So if this has the square root, we can just continue because our number is never good here. So essentially we're looking for a number for which we don't have the square root in our set. So then if we do have it in our set, then if the square root, and then if the square root doesn't equal the number, we're good as well. Yes, this is fine. So essentially now we know that this number is the start of a sequence. And then we can basically just keep squaring it until we can't do it anymore. So we can just say like while, and like I said, because this number can be like 10 to the 5th, 10 to the 5th squared is things in overflow. So we'll just keep checking the square of a number, let's say up to 10 to the 3rd, because 10 to the 3rd squared will give us 10 to the 6th, and then we'll never have 10 to the 6th because of the constraints. So we can just say like while num is less than 1000 and num times num. This needs to be in our uniques. So while we have this, that means we're going to continue on with this like streak. So basically, is the square of our current number in here? If it is, then let's square it. So we can just say num times num, and let's append to our streak. And then at the very end, whatever streak we got, we're gonna maximize that with the result. So we'll say result. And then basically, if we had a streak longer than 1, then we want to return it. And if we had a streak of 1, then we just return -1 because we can't have a streak of 1. So you need at least 2. So we can just say return result equals 1. If so, let's do -1. Otherwise, let's return the result. Let's see here. Oh, I think let's go here. Let's see. Okay. Yeah, and you can use this pattern for a bunch of like other stuff. Like I said, as long as you're looking for like the sequence of things that you can check in your numbers, and as long as they can be in any order you want. All right. So this is linear because we go through our numbers. So we go through our numbers once to put them in the set, and then we skip any number that's not the start of a streak. And so basically, all the streaks together will be all of the numbers in here. So essentially, really, we're going through the numbers like twice in here, but that's still linear. Yeah, and we could probably analyze this guy. Yeah, well, I think it just copies mine, but whatever. So hopefully it makes sense. Not too hard of a problem once you kind of realize this thing that you're trying to do. Alternatively, you could also sort, and then the way you would do it with a sort is you would sort, and then let's say your number is like 1, 2, 3, whatever. You would just start with a number, and then you would just keep checking for the squares. And then anytime you visited those squares, you would just like not use those again. So for example, for 2, let's say I start with 2, and then I visit 2, 4, 16, and so on. I would mark them as visited. And then when I get to 4, since 4 is already visited, I would just skip it. So that's another way to do it, but that would be n log n. So this is better. So yeah, hopefully this should be able to do more problems. Maybe not the next couple days, not sure, but definitely like by the end of next week should be able to start doing problems, at least half the problems or something like that. So definitely skipped a lot because that's kind of busy, but we'll get back on it. So hopefully it's helpful. If it was, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.